Our second stress transformation, we're ready to go. We have a state of stress shown here on a stress block. And we'll end up finding all the angles, all the principal stresses, max shear stress, and we'll end up drawing the rotated or transformed state of stress at principal, so at theta p. So in matrix form, this tensor would of course require a coordinate system, so we'll call that xy. And so minus 20 sigma xx, plus 90 megapascals for sigma yy. Shear stress, I've got on the positive x face, got a shear stress in the positive y direction, so this is going to be plus 60. So this is what we would use for equations. I'm going to focus here on Moore's circle. So for Moore's circle, let's go ahead and put our canvas down here. Let's put a nice axis system. Now I know a little bit about the answer here, so I'm going to bias my axes that I give you. So sigma, always just go ahead and write tau with a clockwise positive. That's actually our sign convention. So let's go ahead and figure our initial state of stress. So to do this, we need an x point and a y point. So in the x, I've got minus 20. On the y face, we've got plus 90. And shear stress. So we look at the positive x face, we've got a shear stress that would be causing the element to rotate counterclockwise. Clockwise is positive on Moore's circle sign convention, so that would be minus 60. And up here we would have plus 60. So I'm just going to go ahead and get ourselves a little bit of scaling here. We'll call that 50, call that 100. Over there would be about minus 50. There would be a 50 and a minus 50. So let's go ahead and plot our points, x and y. So we'll do this nice and red. So minus 20, comma minus 60. So about right here, down to here, there would be the x point. I'm going to label it minus 20, minus 60. The y point is at plus 90, plus 60. So I go over here to about 90 and about 60. So right about there, plus 90, plus 60. So comes real simple. I'm just going to connect those 2 points. So I've actually just found the center right there, but I need to calculate it real quickly. So the center of this circle is going to be at minus 20 plus 90. I'm going to take that quantity and divide it by 2. So the center of that circle is going to be at plus 35. So I'm just going to go ahead and label it right there, plus 35. Now I'm ready for the circle, find the radius of the circle. So I'm going to highlight either one of these will work, either triangle above or below. So I'm going to call that R. I would know that that distance would be 60. And this distance goes from plus 35 to down here to minus 20, giving me a net distance of 55. So my equation for R is R squared is equal to 55 squared plus 60 squared. So that's going to give me R equal 81.4. So I'm actually in great shape here. I can find all my principles. At this point, I like to have a little bit of fun. I'm going to try and strike my circle. And I'd like to see how accurate I am. Ooh, that's not bad at all. So I already know the center of that circle. I know the radius of the circle. So sitting right there, I would just calculate that as 35 plus 81.4. Easy enough. We'd also have, so that would be 116.4. Sigma 2, calculated by the center, 35 minus 81. 0.4, and that would give a value of minus 46.4. So we have lots of these values already coming together for us. So to find the angles, we just need to start with an angle. So I am going to label that as the pink theta. So the pink theta, the tangent of it, is going to be equal to the opposite over the adjacent, 60 over 55. That's going to tell me that the pink theta is equal to 47.5 degrees. So now the theta games has to begin. And so to find my angles, right, theta p, I'm going to take the x point. I can go two directions. I could go clockwise or counterclockwise. So if I just go taking the x point and putting it over at sigma 1 at the principal, that strike would be 2 theta p. So looking up, all right, looking up at the picture, I would have 2 theta p plus the pink theta. That would equal 180 degrees. So I'll just go ahead and plug that in. That would give me theta p, gives me a numerical answer for theta p, and it gave me a direction because I struck, right? I struck in the counterclockwise direction. So that would tell me that theta p, right? One answer for theta p is 66.2 degrees. Right? The other answer, or if I took the x point and moved it to sigma minimum, that also would be 2 theta p. So my other answer for theta p would actually be 23.8 degrees in the other direction. And again, those are 90 degrees apart, taking into account their direction. So at this point, I'm going to go ahead and just draw our answer. We're going to draw the rotated stress blocks. Let's give ourselves another piece of paper here. So right here, we're going to take, and I'm going to rotate that thing 23 degrees clockwise. So there's the original rotated. I'll do it nice and dark here. It's going to be sitting just like that now. I can go ahead and label that as 23.8 degrees. And remembering by going 28.3 degrees counterclockwise, the original x-axis was sitting here. The new x-axis would be sitting down in that direction, x prime. Right? I took the x point and rotated it to principal in the clockwise direction. So the new x point is sitting at 23.8 degrees in the clockwise direction. So what are my stresses? What's on the x prime face? It's going to be minus 46.4. So I'm going to draw an arrow going in. I'm going to call it 46.4. And on the y prime face, right, whether I realize it, as I moved that point there, this point now is sitting on the at principal, and so the answer on that face is a big tensile stress of 116.4. And we'll take a moment and just reflect here. Right, this picture works for either answer for theta p. So if we go back to the answer where we rotated 66.2 degrees counterclockwise, right, in that case we would have started with an element looking like this. Right, with an x-axis sitting there, we rotated it 66.2 degrees up. And so the original x-axis is now sitting up right there. And on the x-axis, right, on the x prime axis would be sigma 1. So I would have the big tensile stress. 116.4. And on the other, the y prime, we would have 46.4. So you get the same answer, right? Either rotation, either direction. And just to finish this, let's go ahead and maximum shear stress would be R. And to get to R, we're going to take that X point and we are going to rotate it to vertical, right to there. So that strike would be 2 theta S. So let's just kind of look at the geometry on here. So looking at my picture, I would see that 2 theta S is going to equal 90 degrees plus the pink theta. So you see the pink theta right there. Right? I'd have 90 degrees more. Right? That entire strike is going to be what theta S is. So if we solve that, plugging in the number for theta, for the pink theta, we'd end up with an answer. Theta S is equal to 68.75 degrees.